Yes, thank you very much, Asaf, and thank you to all of you that you are here and want to listen me talk about test containers. Let me share a portion of my screen that contains a presentation. Okay, so yes, I want to talk today to you about integration testing with test containers, and in general, I move the chat here or whatever. In general, we can try to keep everything interactive. So I'd be happy to have it interactive, meaning if you have any questions during the talk, feel free to ask them. Here already Asaf is writing. Exactly. So go ahead and yes, then we can have a fun session together. Yep, a little bit about myself. Yes, my name is Kevin, and since a couple of months now, I'm a software engineer at AtomicJar, which is also, as Asaf said, a new company that has been founded by the test containers team, basically. So we say AtomicJar, the test containers company. And very soon, I think you will also hear more and learn more about the products we are developing at AtomicJar. Before this, I was 2 years back in academia to work on my PhD, and I was supposed to do my PhD on the topic of blockchain and the use case of blockchain for scientific research use cases, but I more or less put this in standby for now, although I'm officially still a PhD student. And I'm also at the side doing some coaching training activities on LinkedIn Learning, but only on the German LinkedIn Learning. Actually, I have a couple of online courses for blockchain stuff and Java stuff. And yeah, I'm one of the test containers maintainers, also independent from the fact that I'm at AtomicJar. I have been a test containers maintainer for some years and the author of the test container Spock Extension. So I hope I can share you some of the insights. So also if you have any questions, feel free to ask, and we can dive as deep as you want into what I know about test containers. And I'm with the Oracle Groundbreaker ambassadors, but that adds no further meaning. Okay, a little bit about my motivation. Maybe the motivation is the same for you, but my motivation as a developer for testing. So quite early in my career as a software developer, I discovered TDD for myself, so test-driven development, mostly through Spock, so the Spock framework, the Groovy-based unit testing framework, and this transformed a lot how I develop software. So testing for me is a fundamental part of my development and software development experience. It's for me the fastest way I can get experience about if my code works. And I hate like the other, when I have to, for certain changes, have to like really build the application, maybe deploy it, click stuff or whatever, see the integrations in a whole work. That is, I don't know, it's soul sucking for me. Yes, so I want to have this test-based feedback, and that's kind of how I personally see testing. And that's also how we look at this talk and this tool. So from a developer's perspective, but of course also if you're a tester or a test automation engineer or whatever, there are also use cases where you can use test containers for integration testing. But I have a developer focused view. And in general, what I want to show or demonstrate that by using something like test containers, and you could also do it with other technologies, but conceptually with test containers or something alike, we can basically put the definition of our test environments as part of our test code, actually following this infrastructure as code approaches to a certain way. And this makes the complete setup of our development testing environments kind of a no-brainer. So we just go, we clone our repository, we build the project, and this will build obviously the project, but also run the test, and not only the unit test, also the integration test, or maybe even further beyond, something that is more looking like system tests or even UI tests, browser-based UI tests at least. And if we have mechanisms that make it easier to maintain and run integration tests, we might rethink our composition of the test pyramid. So if integration tests are not hard to maintain anymore, are not hard to write anymore, and even not that expensive to run, then we might make more use of it, which might be good depending on the application we develop, especially if we think something like microservices. Yes. All right. So before we start, a little side fact I recently came to learn, which I find very cute. So of course, when we think about testing, we always have the testing pyramid in mind. Yes. And if we think about pyramids, we think about normally the pyramids in Egypt, or sometimes we think about the pyramids in South America. But there's a documentary on Amazon about the pyramids in Bosnia. And this here is called the Pyramid of the Sun. It's in Visoko in Bosnia. And it actually is a hill, or it looks like a hill. But there is a kind of archaeologist businessman that is doing a lot of research around this hill and doing archaeologically digging around, but while digging it, he makes it look more and more like a pyramid. Yeah, but they have this story that this is like the earliest and biggest human-built pyramid, yeah, of human civilization, and he even brings like Egyptian pyramid researchers there, and they say then like, oh yeah, is this a real pyramid? Yes, it has the shape of a pyramid, and it is a pyramid. So there are different definitions of pyramids. And yes, I suggest you to look this up, because we will also talk more about pyramids, but different pyramids, and of course a classic software testing pyramid, which is actually, I digged a little bit into the history of it. It's not that old, so it's from the around the 2000s is probably the first time this was mentioned and communicated, and probably by Mike Cohn from the Agile community. He was probably the first one to talk about the testing pyramid in the context of agile methodologies and unit testing and so on. If someone else has other information, feel free to share it, because I love to learn about the history of software development and so on. And yeah, you probably know this. And this is supposed to be an ideal shape, how for a long time we thought the testing suite should be composited, like a lot of unit tests build the foundation because they're easy to write and cheap to execute. Then we have the middle layer that is already not clearly defined anymore. So it's often called it's often called integration tests. But depending on with whom you speak, they call it sometimes component tests, system tests, and so on. There's a lot of fluffiness, and our industry doesn't have the clear definitions there. And then on top, you have, sometimes they are called end-to-end test, functional test. Others just think about the top SCUI tests, but whatever, you have something even bigger at the top. And then in an ideal world, the manual tests that also then the testers maybe execute at the very top. So let's assume the middle, we call the middle integration test, yes? Then how do we define integration tests, or how do I define integration tests in the context of this talk also? For me, the integration tests are those that interact with external systems, external dependencies, external processes or programs most of the time. So if they, for example, talk with another application over the network, interact with the file system, and like the databases are the nicest example, I think, but even something like the Spring Boot test, like if you annotate something with Spring Boot test, it brings up the whole application context and so on, and then you have a lot of integration against the framework. This feels like an integration test to me. What does not feel like an integration test to me is if I have two classes that are under my control that I wrote, and they interact with each other. This is for me a unit test, but other people would already call this integration test. So just that we are clear, for me, integration tests are those that call outside the boundaries of my application. And yes, so we saw the classic one is the pyramid, but there might be other shapes. And one example is the honeycomb by Spotify, but I will come to another example. Others, don't worry. So one is the honeycomb. And this has been talked about by Spotify in a blog post, a very nice one, where they also mentioned that they use Testcontainers for their integration testing. And they say that for their microservices that have a much bigger integration surface with the outside world, so to say, they use a lot more integration tests. So the main stuff they use are integration tests, integration tests, and then less unit tests. They call them implementation detail tests, and something they call integrated tests. Integrated tests are those tests that really integrate against some kind of environment, like something productive environment and so on, something that you maybe can't avoid at the last step, but you want to avoid it in the normal development cycle. And they say having the bigger amount of integration tests gives them actually more flexibility to make bigger refactorings and so on, because in general, integration tests tend to decouple more strongly from the actual implementation. Although you can say good unit tests are also decoupled from the implementation. But if you would try to unit test database interaction using mocking, then tough luck, you will be very strictly bound to the actual implementation instead of testing the actual behavior of when the SQL hits the database or whatever. But I found another nice example while I looked for pictures, and this this is our Asaf here. It was the last time we met in person at Java Zone, and yes, so you talked about the diamond model you are using at Logs.io, which is of course a very similar concept. Yes, where basically the corpus, the foundation of the tests are more integration based, which can also give you more confidence, especially when you write integration heavy applications, integration heavy code. And nowadays in those microservice architectures, we often write very integration heavy code, or when we want to utilize databases to the highest degree, like then we do maybe do stored procedures. We write more complex SQL because it's just fast. It scales very good. Why use the database just as a stupid data store, relational database? That's a shame. So better use the functionality, and to test it, we then use the integration test. All right. Like a short overview how maybe the integration testing facilities we can use developed in the recent times for us as not only Java developers in general. Of course, we all know mocking and might have used it extensively in the past, and also learned some of the trade-off and some of the pains if we have a lot of mocked stuff. And we can look a little bit at the database case because it's just such a prominent example. So we know that mocking database interactions doesn't give too much confidence. And then you tend to bring the logic of working with the data into the application code. That is actually much slower than letting the database do it. That is optimized for this. And but this was very necessary when we just had like shared databases somewhere, and like all the teams were sharing the same database, and it was of course painful. And to liberate themselves from this pain, developers tend to bring then the logic into the application and say like, oh no stored procedures, whatever, everything should be in the application code to become more autonomous during development. That makes kind of sense. Yeah, but then also you probably know a lot of examples where you would just install and configure local databases, test against them, also work reasonably well. Although then you often have the situation you come into a new team and then you have to follow this wiki page that tells you how to install the database, how to configure it, which schemas to import. You have maybe some bash scripts to bring it into certain states and so on. But it was workable, of course, and still is workable today. And through virtual machines, and this was the first start of the infrastructure as code approaches, and Vagrant was a very nice tool for this. But whoever has used Vagrant before might know that it's not that super fast. So it's okay, but it takes a couple of minutes to start a Vagrant VM and so on. Then you normally use it as a stateful environment to then work in, which might pollute. And Docker, ultimately, and Docker and container technology became probably a game changer for us, just because it's so lightweight. It has such a nice, first of all, the command line interface is also very nice. It's very easy to use and to understand as a developer. So I don't know if any of you worked with the more raw container facilities you have in the Linux normally, like those namespaces and so on. Like you can't work with those, but Docker is a super nice abstraction that is very easy to understand and very nice. We have the Docker Hub that gives us so much potential and power to just pull in the images. The image format is like, it was a genius idea from Docker to have this image format, which we can easily share, to have reproducible environments. Really cool. So Docker changed a lot, and yeah, then people were already using Docker, using, for example, Bash script or whatever to spin up environments, also work reasonably well. And then Docker Compose, which was called Fig originally, I don't know, maybe Fig like the fruit, was even nicer because a bit more declarative than writing Bash scripts also on. And I also used this a lot in the past. And I would say with a tool like Testcontainers, the even better way is to directly instrument the Docker API from within your tests to have really the full power of Docker at the fingertips of your code, so to say, yes, of your Java code, because there is actually a very, very powerful REST-like API in Docker, but using it directly is a bit raw. So like a Docker run command you see on the command line would already require a couple of calls to the Docker REST API. And that's where Testcontainers then jumps in to provide a higher abstraction library for you. So yes, I will not talk about Docker in any detail. I assume the knowledge of Docker by now. If someone needs to know something about Docker, like really importantly, then speak now, else I will jump over it. So and now why do we bring now the Docker and interacting with the Docker API into our normal integration testing world? So to make the setup of my development environment basically a no-brainer, that it's part of building the project. And then another part I personally find very important is to have the same mechanism to set up my test environment in all the different stages, like locally when I develop, but also in CI. And now, if we think about certain CI systems, they often provide also facilities to define test environments, like GitLab CI, and I don't know if GitHub Actions provides it, but Bitbucket, I think they have ways in the pipeline configuration to specify, okay, in these steps, I want to have a Postgres database now. And then they spin it up also as a Docker container, which is generally a good feature, but now you have one way to spin up your environment, the one in CI, and then another one locally where you're not using the facilities of the CI to spin up the environment. So that's not nice. We want to have full parity. And we indeed had like strange bugs in the past when we used this approach of the CI handling the setup of the test environment. And yes, then we end up in a world where we don't have to install or set up any external software when we jump into a project. But yeah, obviously, Docker we have to install in this case. All right, so it's time for test containers. And maybe if I can try to get an overview, the ones of you who already know test containers, can you give me a, I don't know what is the easiest indication, like a thumbs up in Zoom or so, thumbs up emoji, if you already know test containers. 1, 2, 3, 4. Okay, so some, but probably quite few compared to the overall group. That would be my assumption. So I will, in general, start from the beginning. But as I said, if you have any questions in between, just ask. And also, like, we can go as deep as you want, or we can go as deep as you want, and I can go. So I can't go ultimately deep. Test containers. So let's look at some code that uses test containers, but we will go to some real life demos as well. So don't worry. This is the general API from test containers. It's an object-oriented abstraction in Java for creating and instrumenting Docker containers. And we have one class, it's called generic container, and this you can use to run any kind of Docker container. So any image you have, it doesn't matter if it's like, oh, there is someone, I don't know, slightly naked, not sure. So you can, any image from the Docker Hub or any image you build yourself or whatever in your company, you can use, you can throw in, and then it's just like doing a Docker run. And yes, this is a new API we now have in the constructor. So you, before you would specify directly the string here, which was a a bit unintuitive in some cases, because sometimes the string was image plus tag, sometimes it was just a tag or whatever, depending on the container. So to make it more explicit, we changed the API to expect the Docker image name, and then this has to be parsed here first. And then it can give you fast feedback if something is wrong there or whatever. And then you specify some more aspects, like, for example, which exposed ports to use, and then you can start. And this is basically then the same as if we would run Docker run. Yes, this one. Let's copy this. Yeah. So this would be the same as this. See. Okay. So with expose, this is like this. This means we tell Docker to publish support. And yes, let me check if I can even run Redis directly like this, because last time when I tried it was doing some unexpected things. Or else I will try with another image. No, it looks quite nice. So now we check Docker PS. Okay, so what we see now when we run with this command with a -p, then this is using the publishing feature of Docker containers, not the port mapping feature, because many people might want to run it like this, like this -p and then say 6.39 bind to 6.39 or something like this. Yes, it's not what Testcontainers does, because if you would do it like this, and that is also something many people like stumble upon when first integrating with Testcontainers, if you would map to a fixed port, then you are making certain assumptions about your system. You're assuming that the port is free and you can map to it. You're assuming that you're not running multiple tests in parallel that might bind to the same port, and so on and so on. And this is also very important for the CI systems to be portable, not assuming that a certain port is free. So we are not doing it like this, we're doing it like this. And then you get this ephemeral port automatically mapped by Docker. You are guaranteed to have a free port there, and then Testcontainers has an API to get the actually mapped port after the container has started. So this is the first thing to keep in mind. And yeah, it's actually a feature. Yes, it's not a problem, it's a feature. It leads to very stable tests in all environments. Then when we do the start here, this is then not the same as doing the Docker run and then continuing, because the Docker run will just start the container. And once the container is initiated, which means the process is created and the file system is created, the run command is finished. But Testcontainers, starting a container means actually more like starting the application inside the container. So Testcontainers tries to be aware of the readiness of the actual application. It's like when you're having a health check or Kubernetes probes or whatever. And for this, Testcontainers brings the so-called wait strategies. The default wait strategy will just wait that it can open a TCP connection to this port. But there are other wait strategies, like waiting for a certain log message. Also waiting for a Docker health check is also possible, and other things. Yeah. So, and that is very important. And this is also one of the reasons why using Testcontainers brings much more stability than just running containers by hand from the command line or executing it from code from the command line, because then you have to add additional code to wait for the readiness of the application inside the container, which Testcontainers does for you. Okay, now I have the container running, then I can do my testing, then I can stop it again. And when I stop it, Testcontainers will clean it up, remove all the resources afterwards. And if you want to use Testcontainers, I have not updated this, sorry. Because today is a nice day, we actually released 1.16.1, and I will speak a bit more about the features we got. But if you want to use Testcontainers, just add the Maven dependency to Maven or Gradle, and that's it. So if you have then Docker on your system, it will just work. That's all you have to do. And then you just use the Java library, the Java classes, interact with them. That's all you have to do. No other installation required, no matter the operating system. Okay, a little bit meta information about the project. Test Containers Java is the main Test Containers project. It's also the one where I'm talking about mostly right now and today. Has been released in 2015 by Richard North, and it's 100% open source under MIT license. And we have by now 52 releases and 305 contributors, so I updated the numbers today so that they are correct. So also a very active community and a contributor community. And we have 3 core maintainers responsible for this open source project. It's Richard, Sergey, and then also me. And I also joined last. I first wrote the Testcontainers Spock extension. And after this was finished and there was nothing more to do at the extension, I just started to also become a maintainer of the actual core project. And then we have forks in different languages, and I don't even know if we should call them forks or re-implementation, but there are test containers library for other languages like Python, C#, Rust. The Go one is quite actively used in the Go community, and they try to provide similar APIs, follow the same ideas to provide your test containers experience in those languages, but currently they share actually no code. No, there are some images we maybe share, but no code. Okay, and yes, there are also some JVM flavor wrappers like Scala and Clojure. Okay, yes, our star history on GitHub. It's quite good for a Java project. So an open source Java project without back then commercial backing over 5,000. That's good. I think maybe we're even over JUnit 5, not sure. Of course, it's nothing compared to a JavaScript project. That would be by 50,000, I assume. Yep, some of the generic features. We saw this example with the generic container support. You just throw in any Docker image you have, and then you can use it. Then we have some specialized support we will also look at now soon in the demo for databases or those event booster stream processing tools like Apache Kafka, Apache Pulsar that just have some of those configurations already built in, like the wait strategy I mentioned. And in case of Kafka, we have to do some tricks to make it easily containerizable. And yes, that's what those do. And the databases have special APIs that make it easy to use them, like getting directly jdbcrl. Then we by now have support for all the cloud mocks. So if you are developing AWS stuff, AWS provides local stack as a kind of a mock service. So it is a real service. It's not like a mock in process or out of process mock. And yes, you can also use test containers then to run it. And in the new release, we also got now support for Azure. If you already have Docker Compose files, you can also reuse them. We have a special abstraction to instrument Docker Compose. And then many people like to use our special Selenium module that will run a browser, Chrome or Firefox at the moment, in a container in kind of headless, but not really headless because it renders everything in the virtual frame buffer, and you can also have a video recording, and then you can use Selenium tests. And I think Edge, we now also have Edge images for the Selenium image, but I haven't tested them yet. We might need to tweak something to make Edge compatible, but since we have Edge on Linux now, it should become usable. Internet Explorer, don't bother, this will never come. And yes, then support for chaos testing. So with something like Toxiproxy, it's quite nice. You can inject, like, for example, failure, like drop network packages or whatever latency and see what happens. Okay, someone asked, Shani asked, when the test fails, the stop commands will not be called. What happens then? Oh yes, good point. Normally you don't call start and stop directly. I will come to this in a second. Some more features. Yes, the dynamic port binding, I talked about this. So always we use the publish feature from Docker, and then you have an API to get the map port. The wait strategy is like waiting for a port or waiting for a certain log message. And then what is probably what we are most proud of, or one of the very nice features, is that we have an automated environment discovery. So test containers will look at the indicators it sees in the system and then kind of assume on which system it is running. So it has to use Docker machine, or if the Docker is configured using Docker host environment variable, or the Docker for Mac, Docker for Windows, and everything is like slightly different, especially if you're not using the command line interface from Docker, but directly speaking with the Docker socket. You have to be aware of where the socket is. And yes, Testcontainers detects this automatically. And thanks to this, also it works very well on all platforms. Linux, obviously, with the direct Docker experience, but the other two platforms that have the Docker desktop, Mac and Windows, work also. We are mostly developing on Mac and Windows at the moment to also provide the best support for the Docker for desktops there. Windows 11 also works, even with the named pipe, so you don't have to expose the Docker daemon via those legacy TCP option. Named pipes work, and also in WSL environment and so on. Okay, now wait, one more slide, then I can answer the question. Yes, it should work in all CI systems. Also CI as a service providers, obviously. We also have documentation for most of them, especially those that require some quirks for the configuration when they run Docker and Docker or something like this. And if you have your own CI system with Jenkins, okay, you have to be aware how Jenkins is set up and that the builders have access to Docker in a way. So else, if the code has no access to Docker, then Testcontainers also can't use Docker, obviously.
Kevin, can you just stop on that slide for a second?
Yes.
Can you maybe, if you know how this works in the, like, for GitHub Actions, like they have their own Docker facade that actually spins up Docker for you, like a Docker. How does it work?
In GitHub Actions, you don't have to do anything. It just works. You just have Docker available when you're in a Linux runner.
Okay, and it's constrained, I mean, according to a plan or something like that? You can spin up as much as you want, or they will say, no, it's
yeah. So you can. So if you configure your GitHub action, you say, okay, I want to run on a Ubuntu. And the default GitHub action is, as far as I know, running as a VM, not as a container. So then you have the VM running, and then you already have Docker there set up. It's set up as a default. And yes, you can spin up as many containers as you want. But of course, the GitHub runner just has a certain amount of resources. So it's using an Azure DS2 instance, which has like 2 cores, 8 GB or something like this.
Okay, so constrained to that.
Yes, and so you can run your own runners also and have more powerful ones, connect them. But if you use the free GitHub actions, then you get the basic machines they have. Yes, and with GitLab CI, it's similar. Also depends. You can use your own runners, or you have the free runners. And yeah, it's actually the same with all CI systems. So most of the time, you have some basic shapes that have a certain power. Yes. Okay. But you're of course right. This is a limitation you are bound to by the CI system you are using there. And yes, it's maybe a bit unfortunate that you are bound to the single machine in this context. But so you are when you're developing locally. And yeah, so this is another topic, how to scale this up to bigger degrees. Mm-hmm. So now I hope I can answer the question from Shani. There are a couple of different ways to use test containers. One, and I would not even advocate for it, but still, one way is to use our test framework integrations. We have them for all the test frameworks. Here's the JUnit one, and if you annotate a field in your test with @rule or @class rule, then you will have the container start and stop before each test method, or @class rule would be before the test class. And yeah, we will see this in action in a bit, and we can talk a bit more about it. And as I said, we provide the same thing for all the test frameworks. Here's the Spock extension. Same thing, you annotate your class in this case with the Testcontainers extension to activate it, and then all container fields in the class will be instrumented by Testcontainers to be start and stop before each test method, or in case of a field annotated with @shared, it will be started and stopped before the class. And for JUnit Jupyter, JUnit 5, really the same story. And also works in this case nice with nested tests. So you can nest them, and then depending on the, I don't know, you know how the nested tests in JUnit work, and it works also with Testcontainers, JUpyter, and Jupyter. And in this case, it's of course no problem. The test fails, but the extension stops the container. Yes. But there is another facility that leads to it not being bad, that the container will not be stopped, which we maybe look at in the demo now. So I will switch it to presentation mode to be a bit bigger. Nee, ich wollte noch enter presentation mode. Okay. So I'm having here a Java project, Gradle project, not 17, it's 13. I don't know, I should update it probably. And I have the brand new Testcontainers 1.16.1 here. And yeah, if you want to use it, just add the dependency. I'm now showing a couple of specialized containers. So then you have the specialized modules here. And if you have multiple specialized modules, you can also use this bill of materials, Maven bill of materials, that then aligns the versions. But it's not that important because they all have the same version. So instead of using the bill of materials, you can also just add 1.16 to all the Testcontainers modules. Okay, and we will see one brand new feature today that we just released today. The example application is on purpose very stupid and boring without any framework code, but of course it also works in frameworks. Just it makes the examples more complex because then you will have to be an expert about the framework already, or not an expert, but at least know the framework. So we keep with plain Java. Just a class like a DTO, like a book we want to save in a database. Yes, so just two fields, name and author, and the rest is just boring boilerplate. Ignore this. Could be a record, and it would be nice. And then we have our repository class, like the repository pattern, that wants to connect to a certain JDBC URL. And then we have methods like saving books, counting the number of books, or finding all books by author, like that what Spring Data repositories would generate you, for example. And I'm just using Java SQL here. So just SQL statements is also not important. We're not that interested in the actual implementation here. And then I have another class that can do nothing more but send out messages to Kafka. Okay, so no useful code, but a lot of integration heavy code actually, because all the interesting things are the SQL statement, or if our interaction with Kafka works as expected. So let's check how to integration test those. And let's start with the book repository one. So yes, I can remove some imports here. Yeah, here, sorry for using the deprecated constructor. I should not do this. Let me update this with the better constructor, which would use like this. Okay. Yep, it's nicer. So as you saw, you don't have to specify a constructor argument, then you get some default fallback image, but we deprecated this because it should be visible in the code which image you use. And now in this case, it will use latest. It's even better if you would write the actual tag. But since I don't have any tag now in my head, I will just use Postgres latest here. But of course, normally to have stable tests, you should specify your images, at least the tag, or even be more specific and use the which is it, like the hash or whatever, like the more specific specifier. Okay. So I'm using now a JUnit Jupyter test here. I have the extension, Testcontainers extension, and then this is a Postgres container that should be instrumented by the extension. Then before each test, this is already the improved one. Let's use the unimproved one first, which works like this. Okay, you haven't seen anything. Okay, so what I'm doing now is before every test, I'm applying the database migration script using Flyway, but it's just a simple script that spins up, that sets up the schema to get the database in a ready state. And then each of these tests here will now get a new database, so a completely new database container, database instance. And with this get jdbcrl, you already see one of those special syntactic sugar-like features of those modules, because this is, as I said, just syntactic sugar. If we look in the implementation, what it does, it builds you a JDBC URL based on the actual map port. That's what I talked about with this publishing to a random port, then getting the map port after container has started. That's what's happening here. And then here, this method has actually been renamed now also to get host, because it is not the container IP address, but it is the address, the IP address under which the map port of the container is reachable. So just to add more confusion maybe, yeah, but now you know it. Okay, and yeah, now we just want to run the test and we see what happens. And the tests are quite simple. So empty repository is empty, and when we save a book, there is one book in the repository, and yes, I can save multiple books and then find them, search for them. Okay. So now we see here some log messages. It detected npipe, for example. So I'm running on Windows here right now, Windows 11. So it detected Docker on the named pipe socket, and it has to pull the image now because I didn't have Postgres latest before. I was using it with the default constructor. I was getting some old image. So let's hope it still works because I haven't tested with the latest image. Yep, this looks good. Okay. Okay, now this was quite slow, but also we got the initial overhead of pulling the image the first time. Let's run again to get a more realistic feeling. And some of the, what takes the longest time is the initial startup of Gradle sometimes. Yeah, because we see now each method takes a couple of seconds. That's already okay-ish. Yeah, it's not as fast as unit test, obviously. It's also not as fast as the H2 test with the in-memory database, but you should consider we are starting a completely new database instance for each test. We can also, if we check here, watch Docker.ps. Oh, I have the Redis here still running. Let's remove this. Okay. Let's run the test again. Now you will see here always popping new containers popping up during the course of the test. Okay, this is a Rio container. I can say a bit to this in a bit. So here Postgres created 2 seconds ago, boom, gone. Now the next one should pop up. So you see we get completely new database containers for every test. And that is of course expensive. This Rio container is a helper container. Test container starts and this is responsible for cleaning up resources after the test, and especially even if the JVM would exit. So if something crashes and so on, that you don't have any dangling containers running around, this process is communicating with the JVM. So JVM is sending a heartbeat. When this stops, then it will clean up all the test containers resources. So that's important to understand. The containers are maximum bound to the life cycle of the JVM. All right, so now we can do a small trick to speed it up, because like having a completely new database container for each test method, that's like just still expensive. Even if we are running containers instead of virtual machines, we have to initiate the whole database engine and everything. That's an expensive process. So while it seemingly avoids test pollution nicely, it's just like nuking the environment to avoid test pollution is just super expensive. Therefore, better to share the container a bit, and the more you share it in your tests, the better. In this case, we share it in this test class. Then just, in this case, I clean the schema and then apply it again, but there are other more elegant ways to clean up data after tests or to ensure no test pollution. And now we should already see that it's much more faster. Before, each test took like 2 to 3 seconds. And now after the initial getting Gradle up, it should be much faster already. Okay, actually they failed all because I did wrong.
Migration script on the same database every time.
Yes, but that's what I want to do. So I want to clean it and then apply the migration every time. That's what I wanted to do. Maybe maybe this has something to do with the new image that it doesn't work. Let me try with the old image, because I'm very sure I did it like this before. Yeah, that can happen when you make some changes live. Okay, so whatever, in the new image something changed, that when you clean and apply here the flyway migrate, it's something different. Also clean nukes away too much of the internal tables or whatever in the new Postgres version. I'm not here to analyze this now, but it's cute to see. But I can show you another thing that is quite cool and that just landed today. And this is now also support, or again, good support for Oracle databases, which was for a long time extremely expensive, like extremely expensive to start the Oracle database, even the Express edition, even in a container, it would take like 10 minutes easily, and it would be a couple of gigabytes big. And we, in the new release, updated the Oracle container module and now are supporting this image from Wenzel, who is actually from Oracle, so it's kind of the official, or not official, but it's a Oracle community image. And now, if you would know the old experience of using Oracle in test containers, you would be very impressed by the startup time we will see now. If you are not aware of the old pain, you are maybe less impressed, but still. Yeah. Any questions while we wait? Because it's still starting up. We can even check here. Okay, Docker. Yes, Docker logs. Yep. So it's doing a bit of stuff. Yeah. Okay.
You got a question?
Cool. Yes. What does the Testcontainers annotation do? So this is the JUnit Jupyter extension, and if you annotate a class with this extension, then the container fields that are annotated with container will be instrumented by the extension to start and stop the container. Oh yes, it's working. So, and it didn't record the whole time, it seems here, whatever, but maybe it was a minute, or maybe it was half a minute. It felt like a minute, but this is impressively fast compared to before, and is a very nice experience you're already getting here compared to before. Please believe me. We can completely omit the extension as well, but let me go for this into this one here. So, because it's still a bit faster, the Postgres. If we comment this out, just the thing that the extension would do is actually not in the before each, but in before all. So since now this is a static field, which means it's kind of class level, then it does this. Okay, right after. This has to be maybe static wall. Yeah. After all. Okay. Okay, this is all that the extension is doing. So it's not that important to use it. And if you use the API directly, it can be, and sometimes be much more convenient, and you can be much more flexible. So, yep, maybe something to keep in mind. Like the test framework integration is nice to have, but it's just a syntactic sugar thing, and you can do the same by hand very easily, especially if you're using test frameworks that don't have a integration yet. Alrighty, then a quick look at Kafka. It's more of the same, basically. We have again a special container class here. And in case of Kafka, it does a little bit more. It also starts Zookeeper for you, but using it is very simple. It follows the same pattern, and instead of get jdbcrl, we say get bootstrap servers here, and then in this test we just send a notification, and then we consume messages to wait that they arrive. This is just all Kafka code. It has nothing to do with test containers actually. And yep, if I run it, yep, we see here the image we use, Kafka 5.43. We see it starting up. It then internally starts the Zookeeper process as well. It does some tricks to make the dynamic port mapping work conveniently for you. And yeah, so now the Kafka is gone again. And this is also pretty nice. And I know a lot of projects that use Kafka use the Kafka container integration from test containers instead of, for example, the embedded Kafka. You also might know that is sometimes very quirky and not behaving like the production Kafka. All right, some more questions about what I've shown so far.
I have a question regarding, a more real life example in terms of multiple services in a microservice environment. I mean, this is, it's nice. It works, obviously. But how about a bigger scale where you need, 5, 10 containers, and you want to have them running in parallel, the start time for them running in parallel? What about those stuff?
So if it can't run on a single machine, this amount of containers or dependencies, then it will not work at the moment with test containers, because test containers will always run on a single machine. Then again, I would question that you need multiple servers running or multiple containers running in parallel for testing the integration slice of a certain part of your application, especially when you do this white box integration testing. It's something different when you have to set up a whole system and do a out of process black box system, black box testing. But this will only work as long as you can start the whole system still on your host. If you need something bigger, if you need the Kubernetes cluster to run your system even, then test containers is not an alternative. It is more for getting this vertical slice or whatever. For example, if you would have a hexagonal architecture like system, like getting one slice of the hexagon and tasting the integration into its ports. That is the idea. That being said, there is, let me skip to this. There's in general a pattern so it depends on the application you have, but if you have a microservice that has maybe 2, 3 systems it is interacting with directly, then a pattern we recommend is called Singleton container pattern. It's also in the documentation, and this binds the life cycle of the containers you start to the life cycle of the JVM, basically. So the idea is to have, for example, an abstract base class for your integration tests, or for all the integration tests that use the same set of services, of dependencies. And then when this class is loaded, you start the containers. In this case, the just in a static initializer block or so on. And yes, then you have them available. And you never stop them actually, because they will automatically stop when the JVM exits, because then Ryuk will clean them up. And that is definitely much more performant, depending on the test suite and so on, as starting containers in each class or whatever. Yes, there's always only so much we can do right now with the test framework support we have. So I know JUnit 5 was exploring test suite concept that would work better. Then you would bind them to the test suite and so on. But this is kind of the workaround. Yeah, that's my answer to the question. All right.
Kevin,
Cool.
is supporting Kubernetes as an engine for running those containers is something on the roadmap?
Not directly, but there will be stuff coming out of AtomicJar in the future also. So, but directly supporting test containers, Kubernetes as an engine in test containers, so to say, we always think about this, but it's not that easy because the abstraction is different. So,
but I mean, in terms of the user perspective, I want to run these containers, just give me the output, this is the ports. It's very similar. I mean, the engine itself is different, but the DSL
yes,
looks very similar. No?
yeah, the DSL might look similar, but like a lot of core code of test containers is bound to Docker Java. And
so you have to re-architecture the whole library just to support like multiple engines.
Exactly.
Yes.
Or to support engines that have an API that behaves differently as Docker. So we can support engines that have an API that is a substitute to Docker. That we can do, but most of the time they are not clean substitute. But yes, so we understand the need for also testing systems that are not that easy to run, for example, on the single CI node, not that easy to run on a single mobile laptop anymore or whatever. So yeah, this is what we have in mind, but nothing I can share directly at the moment. No. But maybe soon, yes. And so we even have we have a pull request open from someone, and yeah, it's very cool that he started the pull request, and we said like, okay, if you want, explore it, where he tried to build this abstraction into test containers to also support Kubernetes. And there were a couple of pull requests in the past for this as well, and we saw people exploring this, but most of the time you end up with 80% solutions, which seem good at first, but then if you really would want to roll it out to your users, and then you have so many edge cases that are not working, then it will be very hard to maintain. So yeah, that's one of the problems. But yeah, there are a couple of things in test containers, open pull requests, where people explore this idea. And I think we understand the problem, and there will be things coming in the future potentially. Let's call diplomatic like this. Okie dokie. Yes, some best practices or patterns I want to comment on that people maybe avoid them. So the first thing is, for some versions, we have the copy file to container API in test containers. There are basically two different ways to get files into containers. We can say like this: copy file to container. Then it will copy a file from the file system or class path into the container. But there is also bind with file system bind. Yes, the file system bind is like the Docker host, Docker volume binding, where you bind a folder from the host into the container. And the copy is just like the Docker copy. The copy will just copy a byte stream over the network into the container. And this is super portable. And you should always use this, because you never know if you are running your tests in an environment where the host that executes the test and the Docker daemon might be different machines. or in different scopes. This happens very often in CI. And then if people run Docker and so on, then the file system binds will not work as expected. So please use copy file from container to container, and you just have good portable tests that will also work in the CI systems, etc., in Docker Compose setups. Yep. Then I've showed you quickly that we have this Ryuk thingy, and this is for cleaning up resources. So the Ryuk, since Ryuk accesses the Docker socket to then kill the containers, it needs certain privileges, elevated privileges, and it doesn't really work in certain environments that are locked down, like corporate CI environments and so on. And then people disable it, and you can disable it. That's why we added the feature. But please only disable it if you understand the implications, because the implications are that you have no guarantee that the resources will be cleaned up. For example, if the JVM crashes or a task is canceled or anything. So I suggest only disable Ryuk if you're running ephemeral build nodes, meaning the build node as a whole will be thrown away afterwards. Then it doesn't matter, then you don't need to clean up because you throw away the whole node. But if you're having a very stateful Jenkins CI environment, then disabling Ryuk is in general not a good idea, because you might end up with a lot of zombie container resources. And yes, because the question just comes very often in the past, Podman is also a topic we would be happy if Podman would support test containers completely, because Podman is also exploring providing a Docker Java socket, and we're working with the Podman team on making Podman more test containers compatible, but it is not a direct drop-in replacement for Docker as well. And since like, okay, we see the demos, people just do an alias from Podman to Docker, and then they run the same commands, but we are not using Docker commands, we are using the Docker socket and the Docker API. So there are some differences with also the way Podman implements this, but I hope there can be better support in Podman in the future. Okay, yes. So test containers 161 today released. Some of the features. Oh wait, there's one question. Let me try to answer this first from Andres. How hard is creating a test container for custom private image? For example, for other servers written in Java having health check endpoint. It's super trivial. It's super trivial. So you would just do something like, let me just write it here. You would say new generic container. Okay, then like here, my image name, tag, blah, blah, blah. If the image is already on your local machine, it will directly use it, or you would have like a repository URL, whatever, and then how is the format, like this something. Yes, so then it pulls it from the repository image, all good. And 1, 2, 3. And then you would, assuming you have a health check endpoint, like a Spring Boot actuator health check endpoint, then you just say waiting. It's waiting for HTTP wait strategy. We have to waiting. I'm not 100% sure about the API right now, but something like this, yeah. So then you say, let me check. Now I wanted to prove how trivial it is, and here I am. HTTP wait strategy. Okay, this one we want to have HTTP wait strategy for status code. Okay, for status code 200 for pass, and then it is like, I don't know, health. Okay, so yes, so this is now will now wait for the Spring Boot actuator endpoint, or you could use other wait strategies, whatever you want. Is there a way to mock a dependency service in case you cannot draw all the dependencies of your dependency? Yes, we have a special module for this, which is mock server. Yep, which you would use for this. So yeah, I would also always decouple dependencies that you don't have to have the whole tree, else it's not possible anymore. So mock server would be the way to go here for HTTP. Yep.
Kevin?
All right. Yep.
I have a question about
Yeah.
the port randomization, because we use a test container heavily as part of our CI and testing environment. But after some time, we ran into issues in the difference between local development environment, like we do in Docker Compose, and the testing environment. So we had to maintain two environments, both for locally and for testing. So if I compare it to the previous testing environment we had only Docker Compose that we use it both for testing and for environment. So it was easier, but we had to maintain the Docker Compose and running the waiting streak and all these drawbacks of maintaining the Dockers. So is there any way or any new feature coming that I can use the test container as part of my local environment instead of maintaining both Docker Compose and test containers?
Yes, you can. You always could actually, but it's not always clear to everyone that you can do such a pattern. And I have a slide for this. Let us jump there. So yes, because Sergey wrote a nice article about this, which I just post here, because ultimately it's maybe easiest to read the article. This is now an example from Spring Boot. So it depends, of course, what kind of application you have. Like JEE might be harder, but for Spring Boot, it works very, very well. And the idea, and we use it also, like internally for development, we use this pattern. So it's a little bit similar to this concept of the singleton I had. So we have an abstract class that sets up our Spring Boot context for testing, basically. Yes, so it has the containers we need, and then it has the initializer, and I think this is even without the new dynamic, how is it called, dynamic property source still. Yes, so now we have the dynamic property source. It might be even easier. But yeah, so this is a class that has all the containers and that configures then the context for the containers. And then you just create another Spring Boot application class in your test sources, for example. And this then can, in this case, what it does, yes, it just executes the initializer of the integration test class. So that's what he does here, yes, in the run. So when you run this application, it first starts this initializer. And then it, yes, you just run, as if you would run another Spring Boot application, you just run this test application, and this will at the same time start up the environment for you. And the Spring guys even do the same for some of their projects, like Spring Security does this, I think. Yeah.
So even if I need to run my test suite against my local development, so it should work. I mean, running the test not on the Dockers I run for the test. I mean, I run my local debug environment, let's say, from IntelliJ. I'm debugging my service. I have my containers running, and I just want to run the test suite against my local environment to debug it.
Ah, okay. Now, this is a different thing. So you have kind of, so what you're saying is you have your environment running, and then the test suite does out of process testing of the environment.
Exactly, because in Docker Compose it's easy. It's the same Dockers, but when I'm using test containers, I had to do this manipulations. So the easiest way I found to do it was to open a debug port on my for my container and just run the whole system in debug mode. But it's not easy.
Yeah, so it depends on what kind of other application this. If it's, for example, if it is a Java
Spring
application, yes, if it's a Spring application, then you can do this. So then you execute. So you have it in the same Gradle project, kind of, and then you start the application from within your tests as a first step in your test. And then if you have but then it's part of the same JVM process, yes, but still it starts everything, and then this same JVM process, but still send us out of process testing against the public endpoints with rest assured or something. Yeah. So that's something you could do, yeah. And then you can just run this whole test as a debug, and then you end up in the debug breakpoints in your other code, if it's the same code base, yeah. Yes.
Cool.
Yeah. So from top of my head, but there might be other patterns.
Yeah.
Okay, someone asked, Mark, a question out of practical experience. Do you have an idea why doesn't Ryuk get downloaded while starting the test container on the corporate environment behind the proxy? Does Ryuk have any special treatment from the downloading standpoint? This could have been if you have a very old version of test containers. We used to host Ryuk in Quay.io from Red Hat, but nowadays we host it in the Docker Hub. So that is my only idea. If it's still an old test containers version, that it's not using the up-to-date one. Alrighty. Yes. So yes. Okay. Cool. Try to upgrade. So yes, some of the features of the new release. Yes, better Oracle support. We saw this. We have now support for Cosmos DB module, Cosmos DB emulator, but in a container. We have a new way to access host ports from within the container, which is nice if you are you want to instrument the container against your application. Like the container has a Selenium running, and you want to run against the locally running application. And before, you always had to use exposed host ports before containers were started. Now we have this. We can define containers as having access to the host. It's a new API we added. If you're using Cassandra, this should start considerably faster now because we tuned it a bit. And also all the other containers, we improved the checking for the open ports in the beginning stuff a bit. All right. Okay. So just one more quick demo of using Compose. I will not go too much into detail. I will just show how it looks if you're using a container in the browser. So now I'm having here a Compose file, and it's like the Docker example application, this voting application you might have seen before on the DockerCon. And I'm using now a Selenium test, but we're not going too much into detail. I just want to show you can have here like a Docker Compose container where you just specify the Docker Compose and it starts this up. And then we have here a browser WebDriver container, and I say, okay, I want to have a Chrome here, and then also some recording stuff, which we'll see in a bit. And let's have this running. We will see here a lot of containers now pop up. So it's at least a little bit of a bigger test at least. And while we wait for this, I can answer Elia. What about the performance improvement? How much it was improved? So the Cassandra is starting up 3 times faster. So this has been considerably improved. Also, the Oracle was before 10 minutes, now it's 1 minute. But the other checks, it's more in the range of milliseconds probably, or maximum seconds of startup. But I assume more in the milliseconds. But still, it can add up. Yep. Okay, now we see many more services are starting, but it's at least still possible on my machine to run this amount of services. And this is now an out of process test. All right. Yes, sure, Mark, you can, if if you want, you can talk directly now.
Hey guys, can you hear me?
Yes, yes.
Hey, okay, if I have a couple of minutes, I think I could really add something to and share my practical experience of using test containers. I am using it for something like, I've been using something like 2 years, I think. So regarding Elias' question, so if I understood, you have test containers running the test suite, all the tests, but then you have to you want to debug your local environment, and for this purpose you have to maintain the Docker Compose, right?
Yes, exactly.
Okay, so what I did, I used to work in some organization that started using the test containers, so from the very beginning, and we had a bunch of Spring Boot driven microservices. And then what I did, I didn't use the way that Kevin explained with the test containers, but I kind of expanded the Spring testing framework capabilities to and provided a series of annotations. Like, for example, if I need, say, Redis, so I used annotation requires Redis that I can put on the test, and this annotation basically was used to import the auto configuration for Redis that starts all the test containers and everything. But since it's a Java code and I managed everything in a Java configuration, I could add the conditions. So because I have a kind of more flexible approach, I could specify some environment variable that, depending on its state, I could either expose a full-fledged test container or alternatively connect to the already running local development. So when I do this, I mean the local database. For example, if I start Redis with Docker Compose or whatever, you know, it doesn't really matter. Like I could run even bare metal Redis. So I could have an environment variable like use local Redis, and the code of the test suite doesn't change. It still requires Redis, but due to the fact that there is an environment variable, I didn't actually start the test container, but instead I used the connection to the Redis. Of course, I had to map the properties of Redis host and Redis port, you know, according to the state of this environment variable. And if I use test containers, I used to have a dynamic port, and if I use a pre-configured Redis that starts out of, I don't know, Docker Compose, I just had a static port in the connection. But that's it. And this stuff gave us a flexibility of running both setups, but without actually changing the code of the test itself. Okay.
Yeah, so that is a nice thing, that test containers, that since everything is around Java code, as Mark said, you can have conditionals. Something else I have seen in the past is that people kind of probe the environment and check like, oh, if already like something is running on this port, then I assume this is the Postgres and I don't have to start it anymore, and the developer wants to do something locally. So it depends a bit on the use cases, but yeah, I would say since we're in Java, we have a lot of power. So the Docker Compose test just finished, and here we see a video recording of the test. So this was now all running in the container, the Selenium, and it was recording directly the video. And yeah, so you can also do this kind of test, like this more UI and end-to-end test. Okay, cool. So someone asked, Christian asked, examples of TC with CI. Yeah, I don't have concrete examples I can show you, but if you look into our docs, into where? I don't know, I always Google if I do CI. It's probably in system requirements. Yes, continuous integration, you see how to set them up. So GitLab CI is some specifics you have to do because of the DIN setup. GitHub Actions works out of the box, or for example here, Circle CI, you have to use a machine executor, for example. So everything should be here. Good. So let's try to slowly wrap up things, because also I have to go to bed at one point. Here is not that late as in Israel, so you're at 10 already. But yeah, so one nice thing people should be aware of, that we have the possibility as an alpha feature to use reusable containers. For this, you have to set the test containers reuse enable property, and then the containers will keep running even after the JVM exits. And I'm not 100% sure if I have it activated right now here, but we should quickly see. So, whoopsie. So what happens then is that you specify a container as with reuse true, and if also the property is set, then the container will keep running after the JVM exits, and then you have faster TDD flows. You don't have to start up the container with every test run. Is it running now? I'm not sure. Yes, it is. Okay, let's see if it stays running. If it will exit, then I forgot to set the property. This is an alpha feature. It's not yet stable, but I know many of our users actually use it. And why this didn't work? Because I did not update this part of the code base, this test now, to be aware that I have Oracle scripts here in there. That doesn't matter. But yeah, in general, this is how you use it. Just add with reuse true, and you have to set this property. And yes, you can explore it, as I said, alpha feature, but some of our users use it. Yep, today 1.16.1 released. Check it out if you haven't already. We are working on some changes in the API. We are working on a maybe breaking out the core library of this Docker or container abstraction out of the actual test containers code, because it's also useful for non-testing use cases, and then have a test framework agnostic core, and then the other things more as modules around it. Get more support and more features into the other language forks to get them all aligned. And yes, I hope there will be some more news regarding test containers coming out of AtomicJar very soon. And yes, that's it from my side. I'm still here for your questions, and if you have any more specific questions how something works in test containers, I'd be happy to answer it, or some challenges you faced in your general working environment working with test containers. Else, check out the docs, which we have here. I posted in the chat, and then of course our GitHub repository. Sorry, I sent this to someone personally, to Shani, because he wrote me, he or she, sorry, I don't know, Shani's she, sorry, because she wrote me directly. So it was, yes, here. All right, these are the links. And yes, thank you. Any more questions?
I've got a question actually, as Mark
Sure.
talking. Have you happened to hear about some let's say possible integrations that could be made in future from the side of guys like Spring Boot maintainers, or maybe I know big frameworks that everyone uses, at least in Java world with the test containers.
So you probably know Quarkus, and Quarkus has this dev mode built in, where they try to kind of say like, oh, okay, there is no Kafka running, so you need a Kafka. Here you have a Kafka, and it uses test containers for this. So under the hood, it uses test containers. We have from the JEE world, I don't know the project name, from the Open Liberty folks, where they also have test containers integration for testability of JEE. And with the Spring Boot team, we're generally in good touch. So they added, for example, this dynamic property source feature to Spring Boot to a certain degree to make it easier to integrate with test containers. So we have this, but I don't think necessarily more specific integration. So there used to be a Spring Boot test containers module, but it's actually kind of a pain to maintain. And we think the generic test containers Java support is better than tighter integration, to be honest.
I see.
Yeah, but so it depends on the use case. Quarkus, as I said, has a very tight integration, for example, which is like a good thing, but also a bad thing sometimes, because tight integration sometimes leads to unexpected breaking, or yes, because they pinned the version of test containers Java, but also the version of Docker Java, and then they upgrade test containers Java, but don't upgrade Docker Java, but they have all the versions pinned, and things become a bit complicated when suddenly also the framework is starting to manage those dependencies and so on. Yeah,
I see. Thank you.
Sure, I will get out the links to the examples. Whoops, where's my mouse? Okay. Oh, I think I'm getting old. I'm sometimes losing my mouse cursor on my screens. Okay, these are the examples. They should be ready to use, I hope. Ready to use Gradle projects. And if you have Docker on your machine, then the test container stuff will also just work. Okay, and yeah, if any of you in the future have any questions, so we have a Slack community where you can ask questions. It should be linked somewhere here in the docs. Yeah, under getting help. So we have Slack. We have, of course, the issue tracker on GitHub, and we also for some time now use GitHub discussions, which is a quite nice feature. If you're having questions that are not directly issues, you can also use GitHub discussions. Although I sometimes miss the discussions because GitHub doesn't yet provide integration with Slack notifications, and that's how I normally get updated about things happening in the test containers repository. But yes, we want to use them more active in the future. I think it's a good way. And yeah, also in Slack, we have a helpful community, I think. So feel free to come in, ask questions if anything is unclear or you have some specific use cases where you need help.